Hi everyone. In this video, we are going to build a API machine learning solution, and based on machine learning solution, we build a API, and then also we try to build a small UI kind of thing that will consume that API. Uh, and after that, we can see how in the industry basically a problem is solved. So it's like a introductory kind of video where it will help you to build a machine learning solution from starting to end in a project manner. So that's why I'm taking this as this data set, a small data set as an example. So you can see this is a mm, Indian name boys and girls data set. So this is not my data set. I just taken randomly this data set from the Kaggle. You can you can sort out to the person who has created for this data set, right? So if you see this data set here, this contain all the Indian names. It's not all the Indian names, but most of the Indians names as a list, right? Is it as a text? So the idea is we will use this data set, right? And then we try to build a machine learning solution or some kind of API on top of that, which will suggest me a similar kind of word or similar kind of name based on that. So it's going to be something like a similarity based algorithm we will use. So first we will uh, create a folder. So I have created this folder. Okay, this name Indian name search. Okay, you can create any folder, whatever name you want, right? Okay, now you can see this is my VS Code. Okay, so what I will do basically, so I will create a structure which will help me in the later part. So I will keep this entire thing in a one solution, right? Where you have so many notebooks where you do basically the research things. Once the notebooks once the research thing is done, you will go for something like building API based on this research, right? And then also you want to build certain kind of UI for the end user, right? So I this Indian name search is going to be the base project folder, and inside that I will simply create three folder. One is SRC. SRC is mostly going to contain the my API and my UI. Okay, that will we will work on the later part. Second is notebooks. So notebooks are as name suggested. It's going to be Jupyter notebook. Okay, and one more folder we will create is going to be for data. Okay, so these are the three folders. So what we will do first, we will download this data. Okay, so I'm downloading this data. So for now it's asking me to log in. You will log in uh, on this one. Okay, I'm not going to log in because previously I have downloaded this data, so I might have that data. So I will copy this data. You can see we have this data, right? So data contain all the names. So you need to understand first that this is not a CSV file. Okay, this is a TXT file. So we need to read this in a TXT format. Then we need to convert that into a what you call the a data frame to do all kind of analysis and all, right? So what we will do, we will create a notebook. We will name it main version 1.ipynv. See, if it's a very big project, then you can name it in a different module like data data module, data notebook, where you will try to write a code which will load the data and see what are the data is all about and all. After that, you may make a separate sheet. In that one, you're going to do the perform the EDA or feature engineering kind of thing, and then you actually go and build the all these things like building model, do hyper parameter tuning, and all of that, right? But in this case, as I know, this is a very small use case. So I'm not going to do that in a separate format, but I will always recommend that you all will do uh, in a separate one. Okay. So what I will do now, so I will import some of the common package that we will require, like OS, like regular expression, like string. Okay, we might use that one. I don't know right now. Just I'm importing some of the random common packages that we basically use when we are dealing with any kind learning kind of work, right? Then simply I will import pandas as PD. Okay. Then I will import, of course, numpy as np, and then tqdm if we need some kind of processing. And now tqdm that uh, pandas to subscribe that tqdm of pandas, right? So before that, as you have seen my earlier video, I try to make a new virtual environment for this project, but right now I'm not going to do because it will take some of the time to do all these things. If you don't know how to create a virtual environment and all, I have a separate video on the same YouTube channel. So I will link that particular video in the I button. Okay. So for now, I'm just using my common one. So I'm just using the my common Conda environment for that. Okay. So I will run that one. Now, second thing is that I want to load my data, right? So first before loading the data, I need to define basically data part or file parts. So as you can see, my file is in this folder. So to go in this folder, you need to use certain kind of command. So this is basically saying that go back, then go to data folder, and after that you will name .txt file. Okay. So this particular path is referring to this folder. Okay. After that, what we will do? So let's define a function read data from text file. Okay. So it's we are going to reuse this same function again and again. So what I will do, I will store all the words in a list. Okay. And then with open, I try to access this file path, right, as file. And after that, I will take this words file dot read lines. Okay. So there is two function in file. One is read line and one is read lines. So it's going to read all the lines, right? And after it's going to read a line, we will do certain things like if any gap is there, if I see this text, we can see that this is a text, right? But it might happen that in some text there are some space in here, a space here, right? All these things we will handle here itself. So basically I will write again words, then I will do words dot. So let's for write for word in words. It's a list comprehension. Okay. I'm looping, so I will get a word, right? And then what I will do, I will basically strip that one and then convert to lower one. After once all these thing is finished, okay. So what happened that I'm assuming that it will run correctly, and then you have this list of word. So in the last, I will simply return these words. Let's go and use that one and see whether it's giving me a right result or not. I will just copy this one and try to access this one. Okay, you can see I'm getting this data perfectly, right? So no problem. So what I will do, so I will store this data in some words. I have I have taken a word, this call words variable basically, and store all the data. After storing the data, basically I will try to do a data frame, create a data frame. So I will provide this as names, right, and words. So I'm just creating a dictionary, so it's become your column name and it's become all the data on the column, right? Because this is a list, you can see. So this will create me a data frame, and then again in the last I will try to see the data. As you can see, data is loaded and it's giving me in a data format, like in a data frame format. So I will now work on this data. So let's see some of the common things in the data. Like I will try to print pf dot save how many data we have, and then we try to say see drop duplicates. Is there any duplicates are there? And then try to see what is the save, right? Also I try to say is any dot sum. Okay. Now, as you can see, there is 55,691 data with only one column, as you can see, names. Okay. And again, once we remove this duplicate, what happened that there are some data which are duplicate. Okay. So we need to do it for permanently on the data set, right? And as you can see, there is no null data. So first, what we will do, we will remove the duplicate. So df dot drop duplicates. Okay, and I will do in place is equal to true. Always remember, whenever you are removing any kind of duplicates or doing in place kind of things, basically removing some of the data from your data frame, always try to reset your index, because later part once you are working, you have certain kind of dependency on the index, it might give you a throw error. Okay, so what you will we will do, the reset the index. Okay, and in places equal to reset index means like you have index here, right? 0 1 2 3 4, right? So say that this 2 is duplicate. I'm assuming that this 2 is duplicate, so one this might remove. So now index will be 0 1 3 4. It's not going to be like 0 1 2 4, okay, because it's only deleted. Re-indexing will not happen when we remove duplicate. Once we do uh, reset index, so it again reset all the index, so now it's become 1 2 3 4. Okay, after that again I will try to see the save and run. So you can see this is matching, so now everything is good. You see, I am not doing any kind of data cleaning and all, right? Because this is almost a clean data. Our purpose here in this video is to not learn the actual machine learning and all. The idea is that how you can take a data, build a solution, and build a different piece which is becoming a product, right? So that's the basic idea. So here you can see this data is almost clean, so we don't have to do any kind of cleaning and pre-processing, all kind of things. So search, how we can do the search, right? So we can use our classical methods also. Like if we do the search based on character, like you have a, we will take this a and try to search what are the a's are there in this one, right? We will take a and then we will search. So if we give any kind of character, based on character we will search, and searching algorithm is based on whatever you want. It might be basically you can write any custom binary kind of search thing which going to work in a log and time, so that will work. But what happened that sometimes it's very difficult to actually give me the more similar kind of result. So say that I have giving AAIR. Okay, so in most of the case when we are working on the binary algorithms or any kind of algorithm, classical algorithm, we need to write custom logics, right? To how we will match this, the input keyboard with this one, and that matching one is quite difficult to do. You need to write lots of codes, or you can use some of the pre-built packages that some third party people has built to do all these things. But I'm not going to do that one. So basically we are in a data science domain, so we basically use a cosine similarity, which is most popular when you are building any basic kind of search engine. Okay, so we will do the cosine similarity kind of work, and based on that, we try to find the similar kind of data in this one. So first, the question arises: what is cosine similarity, right? So let me define like this. Cosine similarity is like you have two vector A and vector V. Okay, and what you need to do, you basically try to match this both vector and try to find out the cosine angle between them. Okay, and less the angle, more similar is there. Greater the angle, it's more far from the actual data, right? So in actual, it's might in actual definition, you can understand more in a mathematical format, but we don't have to go right now in the mathematical things, right? You can search that cosine similarity on the Google or anywhere. You can find a nice formula for that one. Okay, for now we just consider how we can leverage that one. So I have mentioned you that we will find cosine angle between two vectors, right? So first we need to convert this text data into vector format. So for that, I we have two things, like we can use count vector or we can use TF-IDF. Basically, we are not going to use TF-IDF in this case because, as you can see, this is just a one word. We don't need any contextual knowledge or contextual thing in this scenario, because if we have a long text, then we need a certain kind of relationship between a first word or second word with a last word, right? And that relationship might be some basic level of relationship we can able to find by TF-ID. But in this case, it's a very straightforward thing. Okay, so what we will do basically, we will use the count vector. Okay, so what I can do, from sklearn, I sklearn dot feature, I think, extraction, and from the text I am going to import count vector. Okay, this is the first thing. And then again also we can import sklearn dot matrix, I think, dot pairwise import cosine similarities. So these two package I have just imported. Okay, now what we will do, uh, so we will again create a function. Okay, that function will take this one. Okay, don't build, let's not build function in this case. So simply what we will do, first create a vectorizer. Okay, and we will call this count vector, and in this one analyzer I'm going to keep at char. I will explain that why I'm taking this char, and I am also going to take n-gram as 1 and 3. Okay, so let's understand. In count vector, if you see this documentation, okay, you can see here, if I go little bit below and if I go the analyzer, you see, right, it's word based, it's character based. Okay, and this is I think weight based or something kind of thing is there. So we there's two way we can analyze the actual corpus of this particular data when we pass in that one based on a word. But in my case, name is itself a word, right? So I'm not going to search based on the actual word. I want certain more small kind of details, so I will go with character. So once we write something like AB, it will give me certain suggestion like what is the similar kind of name if something word like AB. So based on character, it's do analysis, okay, and it's give me a result. And n-gram is basically like combination, like one word. So in this case, I'm taking one character, two character, and three character. This kind of combination, it will build, and it will build a vocabulary for this one. Okay. So what I will do, I will call this names vectorize, I think, and here vectorizer that fit transform, and I will pass this names. Okay. So I think name is not defined. Okay, so that's my bad. I will basically take this like this one, and then I will run. And if I print this one, you can see it's become something called. You can see this is going to be something like a sparse raw format. Okay, so this is our vector. So we have converted that one and created this name vector for all the names inside this one based on this n-gram and analyzer. And after that, what we will do, so basically we will what we will try to take a query. Okay, so let's take a query. Okay, let's make a function, because we will pass different query, right? And based on that particular query, we will do analysis. Okay, so we define our cosine similarity and for search, and like I will pass names, all the names, query, I will pass vectorizer, I will pass, and name vectorizer I will pass. Okay, so first what I will do, uh, query vector I will create, right? Because we need to match the two vectors. So first, whatever the query we will give, we will convert that into a vector. So we will use this same vectorizer that we will pass. Okay, dot transform in this case only. So in first case we have done a fit and transform. So first it will learn on the names, all the names, and try to build a vocabulary for that, and after do a transformation, convert this and return, right? In this case I don't want to build a vocabulary, I already had a vocabulary, right? So we use that vocabulary to transform my data into this one. So as I am going to pass a query as a simple text, so I will convert that first into a list, because this transform expect as a list. After that, I just simply find similarity. I will build this similarity. So cosine similarity. So first it will take a query vector, and then so name vectors. So what it will do, this is cosine similarity. So expect like x and y matrices. So don't go details into that one. So basically it's first one, this both require certain kind of vector list. Okay, and try to, so first one try to take one, and one to one try to match with each and every one. So like if we have considered that in name vector we have 5 name vectors, and this query is it's obviously going to be one, so it will do one to one, not one to one, it's like one to many mapping. So from one, take 5, so from first, from second, from third and fourth, try to do matching and give me a result. Like like a percentage of match kind of thing it will give me, and that we will use. Okay, so what I will do now, so I will just first find out the top indices, like, so in this case I will basically get top 5, excluding the query itself. So whatever the query we will give, apart from this I will want to find the top 5 one. Okay, so what I can do, similarities, okay, dot arg, I think sort. First we will sort that one, and then we will access this zeroth index. Okay, and then from last, because it's going to be ascending order. So from last 6 to -1, I will take. I will explain that in the later, and will show you what will be the result. So it's basically going like, if you have something like 1 2 3 4 5 6 6 like, and 7. So from last, so it's saying that count from last it's going to -6 index, and just leave that the first index, kind of thing it will do. Okay, so it will work like that. And then I will simply filter this top similarity piece. Okay, and here in this case, what I will do, I will basically perform some of the task. So let's build something like that. So I will build in this one something that is going to result. So for I in top indices. Okay, and if I and length of this is name, something is there, I'm just keeping a check. So basically it's saying that you will look through this all the indices. So give me indices one by one and check whether this name is uh so I am passing this name. Okay, remove that one, we don't need right now. For that it will work. So in this case I'm just looping and taking indices one by one. Okay, so first I will filter this from the name. So this is going to, in this one I'm just passing the actual name, and I will filter that one. Okay, and after that I will just do the similarities, so 0 and I. So it will give me the top similarity. Okay, and then I will return top similarities. I hope this will work. Let's do this examination. Okay, so I will take query as Rahul. Okay, and then I will simply type top similarity similarities. I will just find. So it's going to Cosine similarity search. Okay, and what we will pass, names we will pass, and then we will pass query, and then we will pass vectorizer. Okay, and then we will pass names vectorizer. I think it will work. And name, it don't know, so I will copy this one. Instead of this I will pass this one. Okay, and then I will simply try to print some message first, like top 5 similar names to, something like that. Okay, and then basically do format, and I will use this query. After that I just name and similarities, similarity similarity. Okay, in top similarities. Okay, and then simply print something like f. I will take this as, sorry, f string. So in this one I'm going to give a name. Okay, and after, what we'll do, cosine similarity. Okay, and in this case I am going to use this similarity, and I think it's going to be 0.2f. Okay, I hope this will work. Let's try to run. Okay, okay, as you can see now it's working. It's Nahul, Rahul, Raj, Rahul. So, and you can see there are some similarity score are also given by them. Okay, so it's nice, right? So I think it's working. So now what we will do, we will try to save this model. We will, right now we are not doing any kind of tuning and all, so that you can do, you can use, you can basically, uh, what you can do, do repetitively work on this analyzer and ngram that you can do, but for now I'm just skipping that part because this video becoming much longer, right? So now you can see these are the all names we have. And after that, what we will do, I just simply try to import like joblib and then joblib dot dump. So what I will do, names. So names, I will simply df dot names. I will dump vectorizer. I will dump names vectorizer. I will dump because once we are using these things, we will use these all these things like for decoding what is the actual name, right? Actual vector we will use. For name vector we will use. So these things actually we need. So I'm just using that one. Okay, and then I will name it like names model dot joblib. Okay, and yes, I run that one, and you can see this is one model we have built. Okay, so let's. So I think the first part is completed. So basically, we have built a machine learning solution for that this particular use case. So so that first part is done. Now second part is build a API based on this model. So in this SRC folder, what I will do, I will basically going to build a API. Okay, and for that, what I will do, I will go and create a folder first, and we name it model. Okay, models, and then in this same one I just create man.py script. Okay, and here what I will do, I will write some of the common packages. So before that I need to select a environment, and here in this case I'm just selecting the same environment. So from here you can select. Okay, and then I will copy this particular model and put here in this one. So paste, you can see now the model is there. Okay, so first I will import some of the important package like joblib I will import, and then I will import something like ubcon. Okay, then I will import from fast API, import fast API. I'm using the fast API for in this case. Okay, for better documentation. Okay, if I'm using fast API, I will also might use that this PyLink import base model. Okay, so this is a separate thing. You can search little bit about if you don't know about the fast API. I have certain video about the fast API, how you can start working on that one. Okay, you can see that video. In this case, I'm using that one. You can use any API framework what you like. Okay, and now the frame same. What I will do, I just copy and paste this. Let's not copy and paste. So first I will do from mm, model. Okay, from I think sklearn. I will import at least similarity matrix dot pairwise import cosine similarity. I will import that one. Okay, and one more thing from fast API. I think one more thing we need middleware and dot porous import middleware. For now, we are not going to use this one. Okay, but still let's work on that one. Okay. When we are working on the UI, we have to use this one middleware. So that for now I'm just have a written. So what we will do, we will go simply and copy this function, go here and paste this one. This is going to be our first function. Okay, and after that what we will do, we will do certain subs. We will first make a class, and it's going to be like similar names, and it will import this base model. So it's only for returning all the things, like I'm going to use the name, okay, and then we are going to similarity go, and it's going to be float. Okay, now what we will do, we will create this app, and it's going to be fast API one. Then origin I will simply take, uh, origin is going to be something, okay, I'm not considering right now. And for now I'm just copy and paste one small piece of code, this middleware, and I will comment this one. So once we require, we will use that one, okay. And after that, what we will do, we will basically load, what we will load, the model starting point, okay, we the point. So for that, what we will use, we will use names, okay, vectorizer name and names, I think vectorizer. So we will go and copy this one. It's going to be best one, that copy, we will copy, just copy this one. You can name anything, but it's okay that if it is consistent or not, okay. So we will copy, and there is something called this name is there, so we will copy this one also. And like job lib dot, I think load might be there, and we will put that one. Again, you can see this is inside the model, right? So I will do dot slash models, and then it will go to model, and then it will run, okay. So first thing is done. After that, what we will do, we will create a basically get API, app dot get, and in this one I will call it search, 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 and then we take a query, okay. And async we will make for now, async search similar name, okay. I have given one name like such similar names for the function. Then we will take a query of type string, okay. And after that, what we will do, we will find again the top similar things, okay. So again, the way we have done here, I think this same thing we will take, copy that one, and simply paste here. So of course we don't have this one, so we name it name. So it names come from here, vectorizer comes from here, this one comes from here, and this query comes from the user, okay. And so for query also we can do something like a strip, and then we try to convert that into lower format. So that we will do. And after that, once we have all the top, we will create a result. So result is going to be something like similar names. The model we have built, actually this similar name, we need to convert that into that format result. So names, I think it's name, okay. So name is going to be name, and then similarity, I think similarity score. So I will copy that one. It's going to be better that we will copy, and then SCOR score I will give. Okay. So it's a, of course, it's a list comprehensive. So we will take a name and SCOR score from top similarities. So from this one, name and score it will take. So as you can see here, it's giving me name and a score. Okay. so that it will take, and based on that basically it's going to return the result. So why it's giving me error, I don't know. It's not closed. So actually I have closed that one. Okay, from not it's in, from name and score in top similarity. So I think now it might work. Okay, let's see whether it's working or not. And then if name is equal to main, and you will use ubcon.run, and I will provide this a app to run. Then also I will provide some port 4020. I will give some of the Docker thing is working in my local, so I'm just changing the default port. Okay, and I will run. So you can run from here also, but it will going to give me error. You can see. Sure. So why it's giving me syntax error? Okay, it's going to be 4. Okay, now try to run. So as you can see, we will run and it will say that okay, this path is not valid. So no such directly is there. As you can see from the logic, we are correct that it's inside the model, and then this one, right? So always remember when you are working on this kind of project, when you run this one, this will run from here. Okay, and then it's try to search all the path, and from here if you give him the path something from here, so it might work. So let's try this one. So from here I will go to src. Okay, and then I will go to model and then run. Let's try to run that one. It's working, I think, but okay, it's working. You can see it. Okay, so from here we need to think when you are running from here. If you don't want to run from here, you just want to run from this exact dot model dot name, then try to run this from here. So go to the there and run that one. For now I'm not doing that one. Okay, so I will go there like localhost 4020. Okay, and detail not found, it's okay. So I will some go docs, and you can see it's giving me a certain kind of UI. It's a swagger UI. I will something like Rahul. Okay, and if I give him, it's giving me a result. Okay, so now it's giving me a result. So in this result you can use that one. So I think one part of this video is done. The another part is going to be something like building a UI based on that I will do in the next part, because if I do in the same part, that is a very different technology. That is I probably going to use Angular for that, and it will take little time. So I'm not want to take that different technology in the same one. So I will take a separate video for that. Okay, for now you can understand that you can take our open source data or any data, build a simple small uh, machine learning model, build the API, how you can use that one. So now you have a API, you can build a in when I build a basically UI, you can see that you can give that URL to anybody, and he can, if they want uh name search engine they have. If I something like rah, it will work. It will give something like okay. And this is a perfect example. See, it's rah. So here rah is there, rah is there. Okay, rah is there. It's look like it's a similar, but it's not azur. And if I search again, it's giving me certain kind of result. Okay, and so Azure is more similar to Zur. Okay, Ura. So these kinds of things. So not much similar like Zuri. If you write certain classical matching kind of algorithm, Zuri is very difficult to find, but it's looks similar, right? A Zura to a Zuri. Okay. So we have a product right now. You can use this product in any way as a plugin in somewhere or as a UI. So I will build UI in next video. So thank you to sticking in this video, and I hope that this video will help you to build your own open source projects or build certain solution. In the next video, I'm going to build a UI. So make sure that you subscribe for my channel. Thank you.